Good morning everybody, this is Dr. Michael, Associate Professor, CSC Department, MLR Institute of Technology. Today we are going to discuss octal to decimal conversion and vice versa. We will also consider the fractional part. So first of all, what we are going to discuss today is why we need octal to decimal conversion. First we will discuss that, then we will discuss the conversion from octal to decimal, and then we will also discuss the reverse conversion, which is decimal to octal. All this we are going to discuss in this video. Why we need to convert octal to decimal? Because it is essential for us to work with octal data. Any technology, it evolves with time. First one technology comes up, then a better technology is developed which overcomes the technology, the drawbacks in the technology which was developed first. This is a standard way where how a technology evolves. So now initially the octal number system was used, later on the hexadecimal number system was widely used. All this we have already discussed in our previous videos in detail. So this conversion will help us to work with octal data. Computer can understand binary, too many digits, compression of digits gives octal representation, gives compression of those too many digits, right? And this conversion will help us to work with octal data because we humans, we are comfortable with decimal number system. Computers are comfortable with binary, octal, hexadecimal, hence we are studying this conversion. Then in Unix, octal notation is used to represent file, permissions, conversion and managing permissions. File permissions, okay, in Unix is based on the octal notation. Also we consider the conversion that aids in managing permissions. So this conversion will help us to understand the historical research because, as I said, technology evolved. After octal we had hexadecimal. Nowadays octal is not widely used, hexadecimal is widely used, but learning this conversion will help us to understand the historical research, again which is your past technology. Okay, so directly we will go into the details of converting a decimal number to octal number. So what we will do now is, suppose if we have to convert 12.7, okay, 12.7, if we want to convert the decimal number 12.7, if we want to convert to octal, what we do is, the 12 we will consider separately, 0.7 we will consider separately, we will combine both to get the result of the conversion of decimal to octal for the value 12.7. So this is as good as solving a separate problem, that is converting 12, which is decimal number, base 10 indicates decimal number, we need to convert it into octal number, means we need to convert it into base 8. So how we do that? In the previous video I taught you how to convert a decimal to binary. There we continuously divided by 2 because bi in binary stands for 2, oct stands for 8, so we need to continuously divide by 8, and then whatever the remainder we are going to get, we have to consider. So 12 by 8, quotient is 1, okay, 8 into 1 8, then remainder is 4, so 8 plus 4 will give us 12, so remainder we get is 4, okay, very simple, 12 by 8, remainder is 4. Then this one we will again consider here, again we have to divide by 8, 1 by 8, quotient is 0, and then remainder we get is 1. Now what we need to do is, we need to consider only the remainder part from bottom to top. So First comes 1, then comes 4. So 1 4 to the base 8. 12 to the base 10 is equals to 1 4 to the base 8, and we have successfully considered a decimal number to octal number. Now we will consider what if you have a fractional part. So what if we have a fractional part? This 12 already we have done in the previous slide. Now we have to focus. If you take out 12 from 12.7, what is remaining? 0.7 is remaining. So now we will focus on that 0.7. Next, for the non-fractional part, which is 12, what we have done in the previous slide? We have continuously divided by 8. We have considered division by 8. Now, for non-fractional part, if we consider division by 8, so logically for the fractional part we have to consider multiplication by 8. So now what we are going to do? We are going to continuously multiply by 8. So take 0.7 out of the 12.7. First, if you multiply by 8, okay, 0.7 into 8 gives us 5.6. Take out the non-fractional part, which is 5, okay, right. Take out the value which is to the left of point, right. Take that out, write that down here. So it's as good as you are doing 5.6 minus 5, okay. We are doing 5.6 minus 5. So what remains? 0.6 remains. That 0.6, the subtraction of these two, that 0.6 we are going to write here, okay, fine. So the rules are very simple. We will take out the digits which are to the left of point, we will take them out, and whatever is remaining we will write here, and we will repeatedly multiply by 8. So 0.6 into 8 gives us 4.8. Now the same process, take out 4, we are doing minus 4. What remains? 0.8 remains. That 0.8 we are going to write in the next step. Again 0.8 into 8 gives us, okay, 6.4. Take out the 6 from it, 0.4 we take it here. 0.4 into 8 gives us 3.2. Take out the 3, take 0.2 here, multiply it by 8, and then again we are getting 0.2 into 8 gives us 1.6. If you take out 1 from this, we will again get 0.6, okay. Let us discuss the last step again. If you take out 1 from this, we are going to get 0.6. And 0.6 already we have done. So from this what we understand is it is never going to end, fine. So you know very well, after point, whenever you divide, you could get an infinite series of numbers, okay. When precision is not an issue, you will stop with few digits. So here we are stopping with 5 digits. After the point, to the right of point, we are only considering 5 digits, fine. So here we can stop, but now you have to take all these digits from top to bottom, okay. So please don't get confused. In the previous case we took bottom to top, in the previous case we took bottom to top, the remainder. Here we are taking out the digits which are to the left of point. We are taking out the digits to the left of point. We are writing them here. But now we need to consider top to bottom. So 0.5, 0.4, okay, 0.5, okay. After point you have 5, then 4, then 6, okay, then 6, then you have 3, then you have 1, 1, okay. So in simple words, all these digits we are writing here, okay, all those digits we are writing there, fine. So In this manner, we were able to successfully convert the decimal number 0.7 into octal number, and the result we got is 0.54631, so on. Octal number we represent by base 8, decimal number we represent by base 10. Now what we need to do is we need to combine both. 12 we have done in the previous slide. What is the result we got? We got 1,4. And 0.7 we have done in this slide. What we got? 0.54631. Combine both. 1,4 which you got in the previous slide, 0.54631, so on, which you got in this slide. Combine both together. So that gives us 12.7 to the base 10 is equals to 14.54631, so on, to the base 8. Okay. So we have successfully converted. So we have successfully converted this decimal number to octal number. Now we will see how to convert an octal number to decimal number. Now this is similar to binary to decimal. There what we have taken weights in powers of 2 because bi stood for 2. Now for octal, oct stands for 8. Fine, oct stands for 8. So what we need to do is we need to continuously, okay, multiply of course by 8, but here we have to consider the weights. What do I mean by that? Here we will start from point, go towards left, and then at this place we will consider 8 power 0, at this place we will consider 8 power 1, and then we will start going from point towards right. Here we will consider 8 power minus 1. Next position we will consider 8 power minus 2. Okay, next position we will consider 8 power minus 2. So 5 into 8 power minus 2, okay, plus again this part, okay, 5 into 8 power minus 1 plus again next this one 4 into 8 power 0, and then again 8 power 1 into 8 or 1 into 8 power 8. Okay. So all these 4 we need to add. Okay, for your benefit we are writing that once again here. The same thing, okay, we are writing here once again. Fine. 5 into 8 power minus 2, 8 into 8 power minus 1, 4 into 8 power 0, 1 into 8. And that if you use your calculator and simplify, this is what we are going to get. Okay. So just by using this simple process, what we have done, we were able to successfully convert a octal number to decimal number. So what all we discussed? We discussed regarding octal number system, decimal number system, octal to decimal conversion, decimal to octal conversion. All this we have seen in today's class. Of course, some parts of it we have already seen in our previous videos. So that's all for today's lecture. Thank you so much.